Good morning.
Good morning.
Good morning.
Good morning.
Okay, looks like everyone's there in Joseph City, except Jill and Holbrook. We've got everybody there. Is that right? All right. So, did anybody do anything amazing over the weekend?
General conference was amazing.
All right, that's cool. So, did you learn something new?
A few things. I mean,
Yeah, we don't. I guess we don't have all day to talk about it.
yeah.
All right. Anybody else?
I went to the car show in Winslow.
The car show in Winslow.
Yeah.
Is that like the Route 66 thing?
Yeah, the standing on the corner thing.
Oh, okay. All right. Well, that's pretty cool. Did you hear any of the bands? Did they play music there?
Yeah, they did a little bit.
Little
It was
bit.
mostly live and it mostly wasn't very good.
Oh.
But there's this native guy who sings blues when
Yeah.
there's not big events going on, and he's really good.
Okay. Well, that's cool. Anybody else? Do anything amazing?
And there was homecoming for us this weekend.
That's true. Yeah, I thought I thought Jay, I thought you were pretty amazing on the football field. That was pretty cool. That was a good game. It was a little bit closer than I had hoped. I actually had to stay to the very end, but it was very entertaining. So that was pretty sweet.
Thank you.
Anyway, and you're welcome. Yeah, we were actually joking about Avery's brother and Stan's, anyway, that's another story. But okay, anybody else?
Jeff, Professor Strong, why don't you come to our volleyball games? You would hype us up so much.
I haven't been invited this year. I've been waiting for you to invite
Can you please come to our volleyball games?
Jeff, if you think I get rowdy at football games with your megaphone, just go to a volleyball game.
Yeah,
Go to
Avery is
volleyball
like
game.
our number one fan.
Well, I actually, so when's your next home game?
I start every.
We have a game on Wednesday, and then we have a tournament Friday and Saturday.
Okay, all right.
And
Well,
we're actually on
Our game is on Wednesdays at 6.
at 6. Well, I'll tell you that one might be a little tough for me on Wednesdays because I actually teach until about 6. But anyway, maybe I can see if the teachers quorum wants to go there. So anyway, I have I've been to different sporting events. I have been to football and volleyball games at Holbrook as well. And I do enjoy it a lot. But it's funny because how much volleyball has changed. When I was in high school, it was so much of a slower game than it is now. And if any of you if any of you ever think that maybe well, if you've never seen like a college or Olympic level volleyball, it is unbelievable. And I would highly recommend, if you've never seen a college volleyball game, I mean, I'm talking about the top teams, or if you've never seen Olympic volleyball, it's it'll totally change how you see that game forever, and it's pretty awesome. So anyway, okay, well let's. But thanks for the invite, and I'll try to figure out a way to come, maybe to the tournament. Okay. All right. Well, let's go back to we were on practice, whatever this is, 1C. So if you want to get out your guided notes, let's take a look at that. I'd asked you to determine if this was indeed a parallelogram. Okay. So let's go through that. So what you have to do is calculate the slopes. So if you haven't done that, do it really quick. And then I'm going to call on some people to give me the slopes of different sides here. Okay. So let's see. So raise your hand if you play on the football team for either Holbrook or Joseph City. Okay, so just Jay. Okay, raise your hand if you're on the volleyball team. All right. Avery, so what position do you play, Avery?
I'm the libero.
You're the what?
The libero for volleyball.
What? What is this word you're saying? Anyway, I think you're making stuff up. But anyway. Anybody in Holbrook on the volleyball team? All right. So when's your next game in Holbrook?
So we have Wednesday, it's a home game, and then Thursday we have an away game.
Okay, cool.
Yeah.
Cool. Well, I'll tell you what.
It's tomorrow.
Maybe I'll have to wear I do have a Holbrook volleyball shirt. I'll wear that one day. You tell me when. You want me to wear it tomorrow or Thursday?
Yeah, tomorrow there's a game tomorrow. It's home.
Okay. All right. I'll see if I can wear. It'll be supporting the volleyball teams. So anyway, okay. Well, let's go ahead and get started here. All right. So Ricky. Okay. So did you calculate any of these slopes?
Yes.
Okay. What'd you get?
Do you want me to say both of them?
Yeah.
2 and -1/5.
Okay. So we've got 2 for this one and this one. And then -1/5 for that one and that one. Okay. So is it a parallelogram?
Yes, sir.
Yes, it is. Because if the opposite sides have the same slope, then that means those lines are parallel. So if they're parallel, then you have a parallelogram. Now, what if these slopes were opposite reciprocals? So like, let's say this was 2 and this was -1/2. Then what kind of shape would it be?
A perpendicular shape. I don't know.
Yeah,
perpendicular lines.
parallelogram. And what do we call that?
That's just a rectangle.
That would be a rectangle. Okay. So the rect in rectangle actually means right. It's like a right angle. Okay. So if they were opposite reciprocals, then it would be a rectangle. But as they are right now, it is a parallelogram. So good job, Ricky. All right, next, we're going to go on to the backside, talking about perpendicular lines. So 2 non-vertical lines with slopes M1 and M2 are perpendicular if and only if their slopes are opposite reciprocals. So this is kind of how you write it. M1 equals -1 over M2. Or you could say M1 times M2 equals -1. So, like we talked about last Thursday, if your slope is 3/2, opposite reciprocal, you flip the fraction and change the sign. All right? Okay, so it says for each of the lines given below, find the equation of a perpendicular line. So the way that this question is worded is there's more than one correct answer. Okay, just a perpendicular line. So in this one, if this one has a slope of 2/3, so that means any line that has a slope of -3/2 will work. So I could just say y equals -3/2 plus anything. Okay? Now, for the second one, we're not told what the slope is. So if we want to figure out the slope of a line perpendicular to it, we have to figure out the slope of this green line. So we do our difference in y's over the difference in x's and get -2/5. So that means the slope of the line I want is the opposite reciprocal of that, 5/2. So then I just say y equals 5/2 x plus anything will be a line perpendicular to my original. All right, any questions on that? All right, so go ahead and do practice 2A, both parts. All right, Hannah, what do you have for the first one?
Y equals 9/4x plus 2.
Plus anything, whatever you want. So +2, +3. Okay, good. All right, and the next one? Sierra.
Y equals 5/2x plus 6.
Y equals 5/2x plus whatever you want. Okay? Good job. Any questions on that? All right. Okay, if you encounter a horizontal or vertical line, you cannot use the slope-intercept form. See, what's the slope of a horizontal line? Okay, 0. I see some of you holding up a 0. See, you can't do the opposite reciprocal of 0 because that would give you a 0 in the denominator. But that might remind you what the answer is. See, what's the slope? What's the slope of a line perpendicular to a horizontal line? Or in other words, a vertical line. What's the slope of a vertical line?
It's undefined.
It's undefined because, see, if you try to do the reciprocal of 0, you get a 0 in the denominator, which you can't have. So that's undefined. Okay? So you just kind of have to know that a horizontal line and a vertical line are going to be perpendicular. Okay? All right, so this says, find the equation. Oh, I don't want that. Okay, so let's say I want to find the equation that goes through this point that's perpendicular to x equals 5. Now, here's the deal. There's a lot of thinking that goes on in this problem, but not a whole lot of writing. Okay? This is kind of what you have to think, though. If it's perpendicular to x equals 5, well, x equals 5 means it's a vertical line. If it's perpendicular to that, then we want a horizontal line. And its equation is y equals a constant. Well, if it goes through this point, then the y has to be that constant. So the answer is y equals 7. All right, everybody okay with that logic? All right, go ahead and do practice 2B. All right, Desiree.
I got x equals -3. So
Ding, ding, ding. Good job. Okay. See, if it's perpendicular to y equals -7, then see, it's going to have points like -3, 5, -3, 2, -3, 0. So it's going to go through -3, 13 there. So x equals -3. Good job. All right, any questions on that one? Okay. All right, given a pair of lines, we can use their slopes to determine if they are parallel, perpendicular, or neither. So we can either be given lines and say, are these parallel, perpendicular, or neither? We can have, a line and a slope and 2 points. And so in all of these, the key is to find the slopes. So no matter how the question is asked, you find the slopes. If they're equal, they're parallel. If they're opposite reciprocals, they're perpendicular. If they're neither, then they're neither. Okay? So let me give you an example. Okay, let's see. Okay, so parallel is the symbol for parallel, perpendicular, or neither. All right, so let's say we have these two equations. So to find the slope of the equations, that's where you solve for y. Put it in slope-intercept form. So here, subtract 2x, divide by -7. And so there's the slope-intercept form. All we really care about there is the slope. Let's do the same thing here. Solve for y. Subtract x, divide by 3, and we get it in slope-intercept form. So all we really care about there is the slope of the green one. So now we compare them. Are they equal? No. Are they opposite reciprocals? No. So the answer would be neither. Okay? All right, look at another example. Let's say we're given this set of points and this set of points? Are the lines connecting these 2 points and the line connecting these 2 points parallel, perpendicular, or neither? Okay, so then what we do is we calculate the slope here, and since 1 and -1 are opposite reciprocals, then the answer is these are perpendicular. Okay? Any questions on that? All right, so try practice 2C, both parts, please. All right, so Jocelyn, what do you have for the first one?
Is it neither?
Is it neither? It is. Well, there's the attendance. We don't need that. The answer is neither. So, oh no, it's perpendicular. I must have been looking at the wrong problem. Okay, so the first slope is 3/7, and the second slope is -7/3. Since those are opposite reciprocals, then it's neither. All right? So which of those slopes did you not get, Jocelyn? And I'll go through it.
No, I got the same thing. I just didn't know like the rules. Like,
Okay, so the rule is this. If when you do the slopes, if they're exactly the same, the lines are parallel. If they're opposite reciprocals, so you flip the fraction and change the sign like this one, 3/7 and -7/3, these are perpendicular. And then if it's not one of those, then it's neither. Okay? So anyone have a question on how we got 3/7 and -7/3? Okay. All right, so Sierra, how about the second one?
is it neither?
You got neither? All right, let's see. I got parallel. Okay, so let's go. Look, this one is already in point slope form. So the number in front, that's 9, that's the slope. The second one, you have to calculate the slope, the difference in the y's over the difference in x's, so you get the same number 9. So if the answer is the same, then you get parallel. All right, let's do another one. Let's see here. Okay, so let's do this one. So this line, 2x minus 5 weighs 14, and the line passing through 8, -5 and 3, -3. So I want you to determine if it's parallel, perpendicular, or neither. All right, so Taylor, when you've got it.
It's neither.
All right, let's see. It is neither. So yeah, they're not parallel. They're not parallel because the slopes are not equal. They're opposites, but they're not opposite reciprocals. So good job. This is neither. Okay. All right. Any questions on that or actually calculating the slopes for either one of these? Okay, so that's it for 2.4. All right, now, but you're actually not going to have a quiz on this for a while because this Wednesday you're going to take the chapter 1 test. Okay, and I'm not going to give you assign any quizzes or whatever. Okay, so just the test, and in an hour you should be able to take both attempts. So then what that means is you guys took the 2-1 quiz last week. So that means 2-2, 2-3, and 2-4 you will take a week from Wednesday. So it does make me a little nervous having it so far out because I'm afraid that you're going to forget. So you got to just keep practicing, you guys, so that it keeps fresh in your brain. So you don't forget all this stuff in the next 9 days. Okay? Now, that brings up another point is that I know that the week of Columbus week, I know Joseph City has a day or two off, like the Monday, I think Columbus Day. Holbrook is on their fall break. Okay, just remember, MPC does not acknowledge any of those schedules. So as far as my class is concerned, you need to be here. Now, if it's a situation where you have no control over it, okay? Let's say if you live out on the res and your bus isn't going to run that day and you can't get a ride, and you've tried to get a ride, you can't get a ride, then to me, if the school isn't going to provide transportation and you can't get a ride, that's not on you, okay? So I would consider that like a school absence, and you guys just watch the video when it's posted the next week, okay? So, but you need to let me know, especially if you're gonna miss quizzes or something that Wednesday. Oh, wait a minute. Actually, that seems kind of. Well, I'm going to worry about that next week. Okay. All right. Anyway, so this week be focusing on studying for the test. Okay, that's your big homework. That's what you need to be focusing on, is doing practice. I would recommend there's a chapter review in the book that goes section by section and reviews critical formulas and notes. I would recommend you go through that. That is on page. Okay. So the chapter 1 review starts on page 123, but the little blue part right before it, page 117 through 122, I would recommend you going through those as just kind of a quick review. Make sure that you understand everything. And then I really like how this review is designed, where it goes section by section, so that you know if there's something you don't understand, you know what section you need to go back through. The other thing I like about the review, and then there's a test. Now, the test is more of the length. Well, your test is not even going to be that long. So the review has like 99 problems. The test has 39 problems. And your test is only going to have like 20 problems. Okay, so either one of those is probably more difficult than the one that you're going to face. But I would recommend you doing as much of that as you can. The other thing I really like about how this is designed in the book is that all of the answers, even and odd, are in the back of your book. Okay, so you can do them, check them, work together on that, practice, whatever. I think that would be a great thing to help prep you for the test.
For the test, it is open notes, just like quizzes, right?
It is open notes, open book, but you only have an hour. So that's what I'm saying, is to look up that formula, to look up that example, you'll be able to do that, no problem. But if you have to look up everything, you're going to run out of time. Okay? So you do need to practice. All right? Any other questions about that? Okay, so that'll be this Wednesday during okay. Well, anyway, let's go on to 2.5. Okay. So 2.5 is on linear inequalities and two variables. The big thing here is this is going to be all about graphing techniques, because the way that you show the answer is half of the coordinate plane will be shaded, and that will be the answer. So if you've got good graphing skills, you'll be in great shape on this section here. Okay? So solving linear inequalities, solving compound inequalities with the and or the or, and then graphing inequalities. We'll actually focus a lot on the graphing as we go. All right, so solving inequalities in two variables. Okay, I think of it as in 3 steps. Okay, step 1, you graph the equation. Now, we've graphed the equation several different ways. Slope-intercept method, XY-intercept method, T-chart, calculator, whatever. You've got to get the line. Okay, then the second step is you make the line solid or dotted. Now, you make it solid if it has a or equal to underneath. If it's just strictly less than or greater than, it's dotted. And then finally, when it's in slope-intercept form, you shade above or below. If it's less than, you'll shade below. Greater than, you'll shade above. Now, this is different than how the book teaches you how to do it. So just make note of that. Is that the book does what some of you may remember doing a test point. And sometimes that's okay, but I think this is just easier to note a shade above or below. Okay, anybody need more time on that? All right. So this says solve the following inequalities by graphing the solution set. Okay, so let's say we have y is less than 2/3 x plus 4. Okay, so to get this line, I'm going to use the slope-intercept method. So go up to 4 on the y-axis, and then the slope is 2/3. Now, here, if I go up 2 and over 3, I'm off the graph. So up 2 and over 3 is the same thing as down 2 and left 3. So you could think of negatives with both of them. So I could go down 2 and left 3 to get the second point. All right, now, it's just strictly less than, so I make it dotted. And then I shade below if it's less than. Okay? And that's the answer. All right, now, any questions on that? All right, now, if I have like x is greater than 3, okay, I wanted to do this one as an example for you because this doesn't quite work with the model that I gave you, but I think it'll be easy enough. Okay, so you think x equals 3. The equation is a vertical line that goes through 3. You make it dotted because it's not or equal to. Now, this is the one where it doesn't really make sense to talk about above and below because it's a vertical line that goes to infinity. But on the number line, the x values that are greater than 3 are to the right. And so you would shade to the right of 3, and then that's your answer. Okay? So there's no above or below there, but I think you can figure it out. Okay, so let's do practice 1, A and B. Okay, so I really kind of, I guess you could describe your answer, but I'm going to just put it up here. So first, you put this in slope-intercept form. Okay? So, now why did I start off with less than or equal to? Why did I end up with greater than or equal to?
Multiply by a -1, which flips the sign.
That is correct.
Second.
So that's why when you when you look at, okay, so let's see if I can say this right. There are some students that will look at the original problem and they'll see less than, and then on a multiple choice test, they will immediately disregard the ones that are shaded above. Okay? You can't do that. You have to wait till you put it in slope-intercept form, because now you are going to shade above. So the y-intercept there is 0. So you could think of it as y equals 1 over 1x plus 0, because the y-intercept is 0, and then the slope is 1, or 1 over 1. And so then you make it solid because it's or equal to, and then you shade above because it's greater than. Okay? So, I could ask you a question about this and say, okay, so which of these points is part of the solution? Okay? So this is kind of what your book does. See, the point 2, 1 is not part of the shaded part, so it's not part of the solution. The point 3, 3 is on the line. The solution includes the line, so yes, that is part of the solution. Okay? Any questions on that? Okay? All right, so y is less than 4. I guess I will have not till J. Describe the graph of this, the solution.
So it's just a horizontal line that intersects through 4 on the y axis.
And is it solid or dotted?
It's solid. No. Dotted.
It's dotted. And don't say slotted because that confused everybody. Okay? It's dotted. And then do you shade above or below? So Jay, do you shade above or below?
Below.
Below. Okay? So, again, here we go to, so horizontal line through 0, 4. We shade dotted, shade below. Okay? All right, so which of these points is part of the solution?
B.
B? Actually, let's vote on it. How many of you vote A? Okay, how many of you vote B? And how many of you vote C? All right, so C gets a couple
It's
of votes.
all of them, right?
Oh.
Let's see. Okay, 0, 0, that's right here. That's definitely part of the solution. Okay? So that is, okay? The next one, 2, 4, 2, 4 is on the line. Is the line included as part of the solution? No, because it's dotted. So B is not the answer. Okay, C, negative 4, 17 is way up here. That's not shaded up there. So the answer is A. A only. Okay. All right. Any questions on that? All right, part 2, solving linear inequalities joined by and or. The union of two sets A and B, denoted with the U, is the set containing all the elements that are in set A or set B. You might remember that I talked about a way to remember and or when we talked about sets before, is to think of it as written like this, or an and. So that'll help you remember which is which. All right, so this is graph the solution set that satisfies the following. So 2x plus 3y is less than 6, union y is less than or equal to negative 2. Okay, so, all right, so for the green one, we put it in slope-intercept form, and then we're going to graph it. So we go to 2 on the y-axis. The slope is negative 2/3. We make the line dotted and shade below. So that's the green part. Then we go over here to the red part. Y is less than or equal to negative 2. Well, y equals negative 2 would be a horizontal line through negative 2, make it solid and shade below. So if we're taking the union, then we want what's green or red. So everything that's green or red is part of the solution. Now, if I just change the symbol in the middle from union to intersection, intersect, it would have to be what's green and red. So just this part here in the middle. So if I swapped it out to intersection, then it would be this part that's green and red. All right, so go ahead and try that one. So Caitlin, what is this first line in slope-intercept form?
I have no idea. I have y is less than x plus 4.
So y is less than negative x plus 4. And then the second line describes this one for me. Is it, what kind of line is this? X is greater than or equal to 4.
It's a vertical. What is it?
It's a vertical line. And is it solid or dotted?
Solid.
How about the first one? Is the first one solid or dotted?
It's dotted.
Got it. Okay. All right. So, and then because it's a union, see the first one, it's everything under this green dotted line. The second one, it's everything including x equals 4 and to the right. And since we're taking the union, then everything that's in green or purple is the answer. Now, what if we change the union to intersect? Then what would the answer be?
The pink and green.
Yes, so just this little part right here that's in both colors. Okay? Good. All right, any questions on that? All right, so that's a good place to stop. So we'll pick it up from there tomorrow with the backside of the Student Success Organizer. Any questions, comments, concerns before we call it for the day?
So for those of us that didn't get to finish, when would be a good time to reopen 2.1?
When you talk to your talent aide and ask her when she is available to proctor you, and then you email me and let me know the date and the time. Okay?
Oh yeah, thanks for opening it up, Mr. Strong. I got 4.5 this time, so.
Awesome. Good job. All right. Well, thanks, you guys. Have a great day.
You're gonna